Guys, today we will take a look on some articles. I haven't prepared it yet. We will choose them from the list. Let's take economy, business, machine learning, software engineering, or programming. 8 repos used by the top 1% React devs. Oh my god, that's cool. Let's take a look. I hope it will be that good as he is saying. Let's take a look, guys. Oh my god, this image is animated. Yeah, it's really cool. It's like AI generated, I think. Huh, interesting. Maybe this guy is almost like AI generated. High growth repos you should contribute to today. 8 open source startup you Combinator invested in. Our 5 favorite open source customers data platform. Oh my god, this guy know how to make titles. Oh, I just forgot to disable music for you. Okay, sorry. Yeah. I forgot to enable recording. Oh my god. Oh my god. It's like, like some kind of music. Oh my god. Okay, let's go. 5 favorite. Okay, it's not interesting, but let's go to like guy as a guy. I don't know, like regular guy. Let's take a look on some other ones. Maybe we'll have some better approaches. Identify case how PayPal and Stripe prevent duplicate payment. Oh, it's interesting. 5 achievable deal. Can you please do not recommend this show less like this? The solid principles. Writing scalable, maintainable code. Let's go. Oh, it's like basic. Oh yeah, I think it's good. It's a good article list. Let's start from this one. 8 repos used by top 1% of React developers. Oh my god. It's like, it's like clickbait title. Let's check it out. Hi there. Oh, images. A lot of GIFs. Oh my god, I don't like this kind of articles. If I want to see an GIF, I can like go and see it. But okay, it's maybe funny. Let's do it. Okay. Classic repos, hidden gems. Okay, let's read. Hi there. Today, let's look into 8 repos, React repos that's the top 1% of developers use. And those you have likely never heard of. Ready? Oh my god, I'm ready. Our story behind how we find what's the best developer use in a court in a lot of data digging and some non-trivial modeling. Now at Queen, we rank developers based on their dev rank. Oh my god. What the hell is dev rank? Reputation, central currency, Queen. Oh my god, it's like first reputation metric and this functions to type and what's a Chinese governmental, it's how it's called, it's stall. It was stall from Chinese government. Creator quests, unlocking solver quests. You earned rank. Getting paid for quests. Oh my god. Oh my god, that kind of shit. It looks like shit. I don't want to read that article. I don't like it. It's maybe it's good, but I don't like it. Idempotency, idempotency keys, how PayPal and Stripe prevent duplicate payments. Okay. Have you ever tried to make a failed payment again and suspected that you paid twice? Oh my god, it's like, it's the main problem. It's when you're solving like a lot of problems. This one is like the most hard one. Payment service providers such as PayPal or Stripe use the method to handle multiple requests for same payment. Idempotency keys. Let's increase our domain knowledge by examining this method together. The essence of idempotency in payment systems. Idempotency is a crucial safeguard in digital payment systems, ensuring that transactions are executed just once. No matter how many times a request is sent, its role is vital in handling the complexities of online payments. From accidental multiple clicks the pay button to return payment request failed due to network issues. This principle prevents customers from being charged multiple times for the same purchase. Okay, it's cool. At the heart of idempotency lies the use of unique idempotency keys for each transaction request. When a client initiates transactions, the payment system requires an idempotency key to be included in the request. Who is generating this request? Like probably somebody. who is this? This key often universal UID, yeah, or a similarly robust random string. Okay, is generated by the client. Okay, client. It acts as a transaction fingerprint, allowing the payment system to recognize if the same request is submitted multiple times. It's interesting because in this case, as far as I understand how it works, like client sending the request, payment service checks in Redis cache if the request is processing, probably. And if it is not, it allows going to database and doing some manipulations. And after that, it like removes from cache and returns to client that is succeed. And in case of, for example, like okay, it's like when registered, it's like already registered, transaction is passed, and in this case, it will never, go one more time. It is impossible because in this case, like you have a client who is sending, for example, one, and you are going to payment service. This one payment service sending to Redis that okay, one is processing, or one is processing, just one, yeah. And after that, it goes to all other stuff and so on. And for example, you have a network issue, and in this case, you are just, oh my god, I have network issue. Do I need to click on pay button again? And you click on pay button again. The same request is going to payment service provider API, as it shows here. And after that, you receive, attaching yourself to your previous request. It's an interesting case. I think it's like basic, I think stuff. But it's interesting how they saying that clients is generated on the client. Clients are generated. This maybe it's some kind of client-based UEID, it's like client generate UEID, and when you are storing in Redis, you just add in, for example, some kind of prefix, like user ID or something like this, user ID and his key, and you will never. Yeah, I think it's like good stuff. Client sends a payment request post to the payment service provider by putting idempotency key to request header. Of course, payment service provider checks if idempotency key has been already sent by controlling Redis cache. As I said, if the idempotency key has been seen, system gets current status of 50 execute. Yeah, firstly executed request. Yeah, what I said. You are attached to the previous request. Otherwise, process the request and inserts new payment to database and idempotency key to Redis cache. Yeah, it's like super, like it's good to know. It's good to know, but it's like not that complicated, I think. But I'm not sure if it's hard to, to invent this. It's not hard to understand, but not all easy tasks are that easy to invent. Like, no, not all easy solutions are easy to invent. Payment service provider returns current status. Yeah, and process request for the payment. Oh, okay. No, it's not what I said. It's saying that it's unprocessable entity if duplicated request. Okay. Maybe you just can, for example, with a idempotency key, you can just maybe you can just okay, he's not connecting to it, but it's like when you create, yeah, of course, yeah, it looks like understandable, because in this case you're receiving in on the client side, you just I'm not sure. Probably it is much easier to just block the request, not to attach you to the request, but block the request. To attach you to the request, the server needs to notify somehow the requester. It can't be done, for example, with, in case of JavaScript, awaits, but yeah, it's nice. Yeah, practical example from prior requests and headers including if the request fails due to network connection, it can be separately retried with the same idempotency. This mechanism ensures that despite any potential retries, the customer is charged only once for the intended amount. Yeah, of course, the idempotency key serves as unique identifier for this transaction request, enabling Stripe system to recognize and prevent duplicate processing of the same charge. Yeah, of course, it's important to know the specific name of idempotency key headers can vary across different payment service providers. For instance, PayPal employs a slightly different approach in naming and using idempotency key for its API request. In PayPal case, the idempotency key is provided through the PayPal request ID header in API calls. If you want to see example payment request of PayPal with idempotency key, please see second. Yeah. Efficient retry strategy for failed payments with idempotency key. To manage retries for failed payments without overloading the system, employing fixed intervals with exponential backoff is effective. Yeah, of course, it's like basic, basic stuff when you like increase your time. Utilize the key ensures retries don't lead to duplicate charges, maintaining transaction integrity while preventing additional system expiration timeframes of idempotency key. Have a lifespan after which they expire to prevent the system from becoming overloaded with data. Yeah, of course, it's like they just dropped from Redis cache because you can't, you can't you know, you can't feed your Redis cache with data infinite amount of time. It's like impossible. It's like super impossible. While the specific expiration time frame for also Redis, I think Redis has storage in the file system, but it's not that efficient. Redis is in memory database. As far as, yeah, it's in memory database, but I don't remember if they have like storage on disk. Probably they are. Somebody said me this. Yeah, that's good article. That good article. I can like it. I can like it. 8 likes. It's like good. Yeah, it's really good article. I can easily agree. The solid principles. Let's go. Has anyone ever told you that you write bad code? Huh? Well, if you have, there is really nothing to be ashamed about. I want to answer. Has anyone ever told me that I write a bad code? Not like when you write a bad code, you're a bitch. It was like this solution is bad, and with argumentation. It was not like, oh, it's bad, it's super bad, you need to rewrite everything, I will be here in 2 minutes, you need to rewrite everything, like something like this. No, it was not like this. It was like, okay, this solution is interesting, let's do like a different one, and let's compare with my solution, and so on, like this. But I don't see that. I don't think that it's like it was about solid principles. It was mostly about like logic, like efficiency, and so on and so on. I think like too big attention to solid can lead to infinite development. Yeah, something like this. Because it's like never ending. Has anyone ever told you that you write bad code? Well, if you have, there is really nothing to be ashamed about. We all write flawed code as we learn. We learn all the time. We never stop learning. The good news is it's fairly straightforward to make improvements, but only if you are willing. 1 second. One of the best ways to improve your code is by learning some programming design principles. I'm not sure. Yes and no. Like, okay, let's read more, and we'll have like more complex picture of this. Okay, you can think of programming principles as a general guide to becoming a better programmer. The raw philosophies of code, one could say. Yes, you use some principles, but you always think like, do I need to lead this? Do I need? It's not possible to write ideal code. It's impossible. You need to find an golden center on one side business, on other side ideal code, and you need to find a center to be a really good programmer who are really investing in company, because company is paying you not for programming, it's paying you for the revenue. Yeah. One of the best ways to improve your code is by learning some programming. Now there are a whole array of principles out there. One could argue there might even be an overabundance, but I will cover 5 essential ones which go under the acronym SOLID. I like more KISS. KISS is better. KISS is better. First off, S in SOLID stands for Single Responsibility Principle. Okay, let's check it out. This principle teaches us to break our code into modules of one responsibility each. Yeah. Let's take a look at the person class, which performs unrelated tasks such as sending emails and calculating taxes. It's like, yeah, you don't need to store this information. Like you don't need to not store this information. You don't need to have this information here, like in your person, like how it relates to person. Like you're no. Yeah, okay, yeah. This is good example of single responsibility. Yeah, I can completely agree. According to the single responsibility principle, we should split the person class up into several smaller classes to avoid violating the principle. I like the idea of moving to other classes when you need it. Sometimes you have some kind of, clause, you can place it here, but you don't need to overkill yourself, for example, with a lot of additional stuff. Sometimes you don't need additional class like a mail sender. Sometimes you can just write function, send a mail, and just run the function. You don't need to to have a class with instance and so on, with extends and so on. It's overcomplicating sometimes, but not all the times. It's important. Yeah, like this. I didn't know what to add more. You need to have a limits. Yeah, it's what I wanted to say. It's more lines, sure, but now we can more easily identify what each section of the code is trying to accomplish. Test is more cleanly and reuse parts of it elsewhere without worrying about irrelevant methods. Yes, but I will not think irrelevant methods. It's not irrelevant methods. You can make it work. It's okay, you send a mail. Only here is question from or to this person. Send a mail from, yeah, and send a mail to, yeah, and here you have self, user, and message. Yeah, or send a mail to this person. Okay, in this case, yeah, just send a mail. Yeah, code sends a mail to specific. It's it's understandable. It's not he's saying that. It's without worrying about relevant methods. It's not relevant. It's okay. It's okay method. But yeah, it's easier. I can say that it's easier to write tests. You are it's it's easier, for example, when you have tax calculator, you have calculate tax for person, calculate tax for other people, calculate tax for other people, and so on. And in this case, you will have some kind of you have like basic your class tax calculator, which will have some, for example, additional functions which can be reused in calculate tax for person, calculate tax for any other entity, LLC, and so on, so on, so on. It's like much more convenient to have like all the tax code to be in one place and not in like person and so on. I can say that it's not like irrelevant or that like reuse parts, yes, if he meant that it's like easier to find everything in one place and understand the logic, like you have understanding, like when you see tax calculator, when you have calculate tax for person, for LLC, you see, oh, okay, it's like calculate tax for person and LLC. We have like that functionality. And for example, the functionality of calculating tax for person is the same as for LLC, for example. Yeah, and you can write only one function for that. And you can, for example, generalize. For example, you can take a person, you can take some data. Yeah, okay, in this case, age. And for example, you can take like age. You can take like calculate tax by age, and in this case you have person age, you have here, yeah, you have the function tax calculator, calculate tax by age, and you pass person age, and inside of this function you have person age multiplied by 100, and it's like, it's good, yeah, it's good approach, but I'm not sure if this guy is like giving a right conclusion in this. Yes, single responsibility is important, but not because you will be worrying about, oh, what is this function is doing. No, you will never think like this. You will understand when no, you will never understand what this function is doing. You almost always need to go inside the function to check. And sometimes names are convenient, but like understandable, like easy readable. But sometimes you need to go inside and understand the logic to understand what is happening. Like a lot of times, if you really want to understand and not want just to write code. Okay. Next up is O of open closed principle. I don't think that's open close principle is like interesting because it's like some code need to be closed. For example, some code have some like information which can't be used. Like I agree in this only for in the part of easy, like not using the wrong thing. For example, when you have some class, maybe it's what it is meant about. Oh, but okay, I will say you have some class which have some methods, for example, and some of the methods are, for example, taking raw information, but it's written like take info, for example, yeah, and in this case you need to pass additional information, and like person, also for example some key, yeah, which you don't have when you're requesting, and when you see the method like take info, you think, oh, I need to take info about the person, like I write take info, and I see, oh my god, what's the key? I will ignore it, and you receive an error, and it's like additional, level of how to say this, confusion. And in this case, yeah, probably you need to make this method private, or for example protected, to be able to rewrite it. And in this case, yeah, you and also for that example, also nearby you had like a method public method, take info for person, which generates that key which you didn't had, like haven't had, didn't had. Okay. No worries. Okay, let's add new functionality in the future without directly modifying our existing code. I don't agree about this. It's about refactoring. When you have a strong typed language and you have strict public interfaces, when you have strict typing for public interfaces, you almost never need to worry, and tests of course, you almost never need to worry about the changing already existed functionality. You always need to be careful, because for example, if you see line which is doing something, you need to understand what this line did before. It's not like I will change this line, I will remove this line because it's not needed. No, it's not working like this. It's about maintenance. You need to take this line and you need to reuse it somehow. And like you need to migrate this functionality to your new version. It's okay when you rewrite code, because if we will never rewrite code, we have like piece of crap, like soon, like really soon. Sometimes you really need to like make new principles, to make new versions of your architecture. For example, you need to incrementally increase how easy is working, like how easy it is to work with your functionality and so on. It's like yeah, once a module is in use, it's essentially locked. I don't agree with this. I agree and not agree at the same time, because you need to be careful, yes, but not yeah, this is one of hardest of 5 principles to fully grasp due to its contradictory nature. So let's take a look at an example. Calculate shape. Okay, in this example, shape class handles different shape types directly within calculator method. This violates an open-closed principle because we are modifying the existing code instead of extending. Oh, it means... Oh, it meant a different thing here. This design is problematic because as more shape types, the calculated method becomes more complex and harder to maintain. Ah, I got it, what he meant. He meant, yeah, in this case I agree. Yeah. Yeah, you need to, in case of good programming languages, you have an abstract method. Yeah, I have an example. I have an example here. Center. Yeah. For example, it's not this one. Let's take a different one. This one. Here I have an example of this stuff. For example, we have a base repository, and maybe I can do like this. Oh, it's not, you don't see my okay, I need to go here. Editor, general appearance, no. code completion. Where is it? Appearance 72 imply. Ooh, it's too much. Cancel. Oh my god, oh my god, oh my god. Oh my god. Appearance. Font size. Decrease font size. Oh. Oh my god, it's like piece of crap. How to run this? Insert. Oh my god, it's like piece of crap. Oh my god. Zoom. It's oh my god. How can I reset? Oh, maybe I can like reset font size. Reset font size. Font size. Okay. Restart default settings. Restart and restart. Exit. Oh my god. Oh my god. I hope it will run successfully. Oh, it's closed all my projects. No. Oh my god. Where is it? It's like it's resetted everything. All my no. No. Oh my god, really? Oh my god. It's piece of crap. It's piece of crap. Really? Oh my god. Oh my god, it's like it's really piece of crap. It's impossible that this happened. Oh my god, well, okay. Let's read the article. I hope Goland is not. Yeah, Goland is not. Okay, so it's only WebStorm. But all my project is in with WebStorm. It's like, oh my god. In this example of Go, we defined the base class shape while solo purpose is to allow more specific shape classes to inherit with properties. For example, the triangle class extends onto the calculate array method to calculate and return the area of a triangle. Yeah. By following open close principle, we can add new shapes without. Yes, if we're talking about extending, yeah, agree, 100% agree. It's really good. Liskov substitution principle. Subclasses should be able to be used interchangeably with their superclasses without breaking the functionality of the program. Now, what does this actually mean? Let's consider a vehicle. Let's consider a vehicle. Class with a method called start engine. Start engine, yeah. According to Liskov substitution, any subclass of should also be able to start the engine without any issues. But if, for example, we added bicycle class, we obviously would no longer be able to start the engine because bicycle don't have engines. Below demonstrates the incorrect way to resolve this issue. Race not implemented to properly adhere to LSP, we could take two roads. Let's take a look at the first one. Solution 1. Bicycle becomes its own class without inheritance to ensure that all vehicle subclasses behave consistently with their subclass. The superclass vehicle is split into two, one for vehicle with engine and other one for agree. This one is good solution. I like this one. Next in line, I for interface segregation. The general definition states that our modules shouldn't be forced to worry about functionalities that they don't use. That's a bit ambiguous thought. Let's transform this obscure sentence into a more concrete set of instructions. Client-specific interfaces are better than general-purpose ones. This means that classes should not be forced to depend on interfaces they don't use. Instead, they should rely on smaller, more specific interfaces. Let's say we have an animal interface with methods like walk, swim, and fly. Yeah. Not only perform all the sections. For example, dogs can't swim. Yeah, you need just walkable and so on and so on. Yeah, walkable, swimmable, flyable. Yeah, which brings us to dependency injection. High-level modules should not rely directly on low-level modules. Instead, both should rely on abstractions. Interfaces or I like more abstract classes, but interfaces is also useful. But abstract classes is like, oh my god, it's super good. I so like it. Yeah, this example report generator class. I'm so sleepy. Oh my god, it's like, oof. This article is super good. I don't want to sleep. But yeah, really, I just read this like too many times. I think about solid. In this example, report generator class directly depends on concrete SQL database class. Yes, report generator. Yes, this for now. But what if you wanted to switch to a different database such as MongoDB? It's like, yeah. This tight coupling would make it difficult to swap our like as an example is super bad. It will like almost never happen. Like almost never happen. And if it's happened, it's not the biggest deal you need to deal with, because it will lead like to a lot more problems. Yeah, if you plan good, you will have not too much problems. For example, when you have, for example, one single responsibility, like for database, but it's like, yeah, it's probably, it's not a big deal. It's a big, no, it's not a big deal. It's a big deal, biggest deal. Like I never, to be true, I never meant like this database fetch data. Like when you really have two databases independently. Never saw this. Never. Nowadays I still discuss sub-design principles and whatever they have withstood the test of time in this modern world of multi-party programming, cloud computing, machine learning is solid. Serial environment. Personally, I believe that solid this principle will always be the basic of good code design. I can agree with that. Yeah. Sometimes the benefits of this principle might not be obvious, but working with small applications, but once you start to work on larger scale project, yeah, agree. Because when you have, for example, to-do list, it's like, why do we need that amount of abstractions? But when you have like a huge stuff and you just need to write like basic stuff because you did a good work with planning, yeah, it's like super useful. Difference in code quality in by words, the efforts of learning them. I think it's not possible to learn solid. You need to feel it. You need to use it, and after that you will understand it. It's not possible to learn it. It's only possible to understand it. The modularity that Solid promotes still makes this principle the foundation for modern software architecture, and personally I don't think that's going to change anytime soon. Thank you for reading. Yeah, okay, I can clap you 2 times. Good work. Ryan I'm so sorry if I misspelled your name. Yeah. Thank you guys. See you in tomorrow.